Okay, time to work backwards. Let's try to figure out from this graph what the original function was. Obviously, since it looks like this, it's going to be some sort of y equals mx plus b function. Our original was a line because a line, remember, when we reciprocated, gave us something that looked like this. Well, here is, of course, our asymptote, which, of course, x cannot equal to 3, but that doesn't really help us out too much with a line. Or does it? Well, we know that this line, this point, and this point, all 3 points are going to be invariant points on our graph. Okay? So those are all going to be invariant points. So I know that that point is going to be the x-intercept for my line graph. Well, you know what's really cool? It's easy from this point. Look, find the slope. Rise of 1, run of 1. Your slope is going to be 1 over 1. 1 over 1. There we go. X plus b. So in other words, it's going to be y equals to x plus some sort of x-intercept. And you don't know what it is. Well, I'm sure you could go down here and find it and say, okay, my intercept is 1, 2, 3. But let's say you can't. Well, you know what? Pick a point that's on this graph. Pick this point, which is 1, 2, 3, 4, 1. This point is 4, 1. Substitute it into the equation. This is going to be y equals to 1 equals to x plus b. Subtract 4 from both sides. Subtract 4 from both sides. Boom. B equals to minus 3. There's your equation. Y equals to a slope of 1 over 1. Rise here over run of 1 over 1, which is x. And your b, which is minus 3. There's the original equation. That's how it works. So lines are really, really easy to figure out the original equations on. Let's go to this one. We see this one and we automatically know that this is a quadratic as well. But do you remember how to get this point? Do you remember that point there? That point was based on this. Your x value is always the same for both the reciprocal and the original function, but it's this value that's not. This value is the reciprocal. So if you think this is negative 1/4, what's the reciprocal? The reciprocal then is going to be 4 over 1, negative. Okay? The negatives always are there. Okay? So your reciprocal is 4 over 1. So your original function was at negative 1 right here, 1, 2, 3, 4. There's the point. Now remember, these were the non-permissible values. In other words, they were the point where this graph intersects. So it goes up like this and goes up like that. There was your original parabola. But the problem is, what the heck is the equation for this? We'll go back to the equation of a parabola. Y equals a, x minus p squared plus q. Now, remember, there's your vertex. What is your vertex in this case? It's minus 1, 4, which you determined from this original vertex here of minus 1, minus 1/4. Okay? So minus 1, minus 4 is your vertex. So plunk that in there. Y equals to a, x minus a minus 1 squared plus a negative 4. There it is. Simplify this out a little bit. I'm going to need some more space here. Okay, simplify this out a little bit. What do you get? Y equals to a x plus 1 squared minus 4. The only problem is, what is a? Well, you know what? You have a point. You have a couple of points. You have these intersects right here. Let's use one. Well, let's clean this up a little bit and let's see what we can see. This intersect, of course, is our asymptote right here, which was at 1, 0. Let's plug that number in. This is 0 equals to a x. Well, x is 1 now. Plus 1 squared minus 4. Look at this. 1 plus 1 is 2 squared. So a times 2 squared minus 4 equals to 0. Okay, 2 squared is, okay, that's 4a minus 4 equals to 0. Add 4 to both sides, right? And you get, guess what? Cancels. 4a equals to 4. Divide by 4, divide by 4. So a, in fact, equals to 1. All right, no problem. Now, go back to the original. The original was this. Substitute in 1 for that a, and you've got the answer. So basically, you have something that looks like this. A equals to, there's the 1 that you found, right? And x plus 1, because that's your vertex, squared minus 4. And there's your original function. That's how it works.